process of determining the sufficient volume of a substance is called titration. This is a form of chemical analysis in which the concentration of a substance is determined by measuring the volume of a solution of known concentration. In order to perform any titration, two steps must take place: a preparation of a primary standard solution, followed by the actual titration. This video will demonstrate the steps in obtaining a strong acid, weak base titration, using sodium carbonate as the primary standard solution and hydrochloric acid as the standard solution. The step in conducting a titration is to prepare a standard solution of known concentration. The standard solution is a solution of an acid or base which is measured to a high degree of accuracy. To prepare such a solution, a suitable primary standard used to make the standard solution must first be chosen. The primary standard must have a high purity, be easily and accurately weighed, must not react with moisture in the air, have a high molecular weight, and must be soluble. 1. The sodium carbonate solid must be free of moisture. To produce this, it is placed in an oven and cooled in a desiccator to remove all traces of moisture. 2. While the solid is cooling, thoroughly rinse a 250 ml volumetric flask, a small beaker, and a funnel with deionized water. Place the funnel in the neck of the volumetric flask and place the beaker on an electronic scale and zero the scale. 3. Once the solid has cooled, using a clean spatula, transfer as accurately as possible 1.333 grams of sodium carbonate into the beaker. Step 4. Using a wash bottle of deionized water, add a small amount of water to the beaker and mix until all is dissolved. Step 5. Transfer the mixture through the funnel into the volumetric flask. Ensure all the solute has been transferred into the flask. Wash the funnel, allowing all the water to flow into the flask. Once it is noticeable that all the solute is transferred, remove the funnel. This is done to obtain full accuracy. 6. Fill the flask using the deionized water up to the 250 ml graduation mark. 7. Cover the flask with the glass stopper and invert to ensure the solution is mixed precisely. This has now accurately given a known concentration of the standard solution. With this, the next step of the volumetric analysis may take place: the titration. Step 1. First begin by rinsing the burette with deionized water. Tap water cannot be used as it contains ions and impurities which can affect the results obtained. Then, rinse the burette with the solution it will contain, in this case the primary standard. This helps to minimize dilution as a result of leftover droplets of water. Step 2. After rinsing, add the standard solution to the burette. This is known as the titrant. Carefully note the starting position of the burette to avoid parallax errors in reading the meniscus. To avoid errors, allow the starting position to be at 0. Ensure that the burette contains no air bubbles. To do this, hold the burette at a vertical angle and rotate. Step 3. Once the burette is set up, rinse the pipette with deionized water before rinsing with the solution it will contain. In this case, the pipette will contain the analyte, being the hydrochloric acid. After rinsing, use the pipette to measure 25 ml of the unknown volume of the analyte. Place the solution into a clean flask. If there are any splash droplets stuck on the wall of the flask, use deionized water to rinse it off. This will ensure every molecule of the analyte is in the main solution. Step 4. This step requires the use of an indicator. it is important to choose an indicator that will undergo a sharp color change at the exact equivalence point of the titration. In this case of a strong acid weak base titration, the suitable indicator is methyl orange, containing a pH range of 4.4 to 4.3, and the color changes from yellow to red. Using the eyedropper, add 1 to 3 drops of methyl orange into the flask and stir using a clean, inert stirring rod. Do not add more than a few drops of indicator, as indicators themselves can affect the pH of the analyte. Once added, this will cause the solution to turn yellow. Step 5. Set up the equipment and preferably place a white towel under the flask to make it easier to detect the color change in the indicator without overshooting the equivalence point. Step 6. The titration may now commence. Begin titration by slowly letting the burette's content to pour into the flask. The titrant may flow relatively fast at first, then slowly nearer to the equivalence. The burette should be stopped on the first sign of a color change. For best results, the first titration is discarded and the titration is repeated another 3 times, repeating all steps including cleaning of equipment. In repeated attempts, the rough idea of the equivalence point can adjust the titration accordingly. Before beginning each time, note the starting point of the burette, so you can accurately measure the change in volume each time. Be careful when near the equivalence point. Only let individual drops to drip, one at a time. Stir the flask with a stirrer or in circles after each drop, as it only takes 1 drop to change the color of the solution. Step 7. Once there has been a noticeable color change, the solution has turned red. Read the volume delivered by the burette as accurately as possible by placing a white piece of paper behind the burette marking lines. Step 8. Record all information for later calculations. Repeat the titration another 3 times until a consistent volume of titrant is obtained. Often the first titration will overshoot the equivalence point, as an unknown approximation volume will occur. This will allow for estimation in volume for the other titrations. Once all titrations have been completed, the concentration of the analyte can be calculated. This result is taken by averaging all results, excluding the first titration. Calculating the required concentration or amount of the unknown can be done by using the basic principles of molarity calculations.